Yeah, good afternoon all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? So yes, myself, I'm Vijay. Like I hold 20 years of experience, which includes nearly 8+ years of experience in Hadoop and PySpark environment. So as part of today's demo, I'll be covering the following topics. Yes. Fine. What is big data? Why Hadoop? Drawbacks with the current databases. Hadoop and Spark advantages. Hadoop and Spark job market, right? Yes. Yes. Big data, right? The huge volumes of data. Currently, data is stored in the form of the data storage units, right? KBs, MBs, GBs, terabytes, petabytes, exabytes, zettabyte, petabytes, yottabytes, so on, right? So from TB onwards, like we say it as huge data, right? So you should have seen KBs, MBs, GBs, or even TBs of data. Do you think like petabytes of data is it getting generated? Petabytes of data is it getting generated? Right. Petabytes of data. 1 petabyte equal to 1024 TBs. Already 1 TB is a large storage unit, right? Yes. Yeah, 1024 TBs. Okay. Petabytes of data generation. Petabytes of data is it getting generated in the current real world, right? Examples of it. Petabytes of data generations. For example, social media like Facebook, right? Generating huge data means in a minute how many posts and videos are getting circulated. What is the data generated by Facebook in a minute? How many posts and videos are getting circulated, right? Yes. So huge data. Not only like Facebook. Today, if we talk, lot of other applications are generating data, right? Huge data. Like if we talk, we take 1 minute transactions. Take 1 minute transactions, right? In 1 minute, how many FB posts? What is the data generated by Facebook in a minute? What is the data generated by Twitter? Twitter tweets keeps on generating. Everyone they're querying in the Google, right? Google queries. What is the data generated by Google in a minute? Talk like YouTube videos upload, right? YouTube videos upload. What should be the storage capacity to store all the videos? Email or Gmail messages. Millions and trillions of users using this email messaging. What is the to store all the messages? What is the storage required? And even for bank transactions, or if you talk about the telecom transactions, or if you talk about e-commerce like Flipkart or Amazon, right? Transactions. Everywhere we see like huge data, right? Currently we have got databases like Oracle, MySQL, DB2 SQL Server, right? These are used for OLTP, online transactional processing for day-to-day operations. And we have got we have got some specialized databases used for data warehouse purpose, right? Like Teradata, Netezza, Vertica. These are used for data warehouse purposes, right? For OLAP, analytical processing for data warehouse, right? Yes, but these databases are specialized databases. They can handle data up to some extent, but beyond that, they cannot support data further. Unlimited data storage is not possible, right? So for huge data storage and processing, right, we have got a framework like Hadoop. Yes, Hadoop. Today, if you see comparing the data from the last 50 years, right? Compare the data which was generated from the last 10 years with the previous 40 years, right? From the last 10 years, we see like huge data is getting generated, huge data, right? especially right, the huge data from last 10 years because of usage of technology, usage of smartphones, because of usage of internet, right? Huge data is getting generated, right? From where the data is getting generated, mainly the main sources like social data, we say, machine data, or transactional data, we say, right? From machine data, transactional data, or social data. Social data from social websites, transactional data from day-to-day transactions, from bank or telecom transactions, and from social machine data which are generated from by reading or scanning the barcodes and RFID chips, right? Such data we call it as machine data. And the data mainly occupying three types, right? Mainly three types: structured, semi-structured, and unstructured. Today, if you see the biggest challenge, like handling the unstructured data, means structured means in the form of rows and columns in the structured format, like database tables, Excel files. And semi-structured means like XML files, JSON files. For unstructured data, but today if you see huge data is getting generated, which is taking unstructured format like chart messages, articles, images, videos, all this are called as unstructured. So databases can handle only structured data. Databases can handle only structured data. But Hadoop can handle all varieties of data, structured, unstructured, and semi-structured. So as a solutions to all the storage level problems and processing level problems, right? So as a solution to all the storage level problems and processing, we have got a framework like Hadoop. Hadoop is mainly meant for two things: for storage and for processing. Hadoop is meant for storage and for processing. If you take any technology, right, like C or C++ or Java or .NET, all these they are meant for processing. If you take any databases like Oracle, DB2, SQL Server, all these they are meant for storage. Means if you take any technology, they are either meant for storage or they're either meant for processing, either storage or for processing, right? But Hadoop is meant for both storing and processing. Hadoop is meant for both storing and for processing. It performs both storage and processing. The two: unlimited data, huge data storage, and unlimited data processing. Yes. Yeah. So Hadoop providing, so for storage, does Hadoop use any databases internally for storing its data? So the databases has got some drawbacks. Despite of the drawbacks, still Hadoop doesn't go with the databases for storing its data. It's going with a kind of file system called as Hadoop distributed file system, and for processing is going with an execution model called as MapReduce. Currently we say like Spark. MapReduce or Spark, right? Yes. Hadoop is meant for storing and processing. You take huge data, big data, right? Big data like huge data. You take big data as a problem. You can take Hadoop is the solution. You take big data as a concept. Hadoop as the implementation. So yes. So Hadoop is meant for, right, for storing. Hadoop is meant for storage and processing. HDF for storing HDFS, Hadoop distributed file system, and for processing mapped. You may get one query: when Hadoop is performing both storage and processing, what is the necessity of the current technologies, like current processing and storage technologies, right? When Hadoop is able to perform both, then do you think that they will go away from the market when Hadoop in the market? You need to understand clearly why Hadoop. Hadoop is meant for batch applications. Hadoop is not for Online applications, it's not for online application. There are two type of applications, online applications and batch applications. Online applications, user interactive application, user gives the input, making a online transaction, booking a movie ticket. These are online applications. Hadoop is not for online applications. Hadoop is for batch applications, for millions and trillions of records. If you're making a single transaction, for that Hadoop is not required. For millions and trillions of records, user non-interactive applications are called as batch applications. User is no way required here. User is no way required. Railway ticketing, PNR status, generating credit card statements for millions of customers, right? All this. Yeah. Generate credit card statements for millions of customers. So all these are batch applications. Hadoop is meant for batch. Drawbacks with the current databases, right? What are the drawbacks? Why Hadoop is not using databases for storing its data? What is the drawback of the current databases? Yeah, can anyone say drawbacks with the current database? Drawbacks with current databases compared with Hadoop. So first thing is a limited storage in the case of limited storage in the databases like in GBs or in TBs. Most of the databases, no parallel processing. In most of the databases, we see no parallel processing. Yes. Even if volume increases, speed decreases, right? Volume increases, speed decreases. For example, observe these three queries. Select a total amount from sales 1. It has got 10 records. Select sum of amount from sales 2. That is total amount from sales 2. It has got 1 lakh records. Total amount from sales. It has got 1 crore records. Which query is going to execute faster among these three? Which query executes faster among these three? Obviously, the first query, right? 10 records. 10 records, right? Yes. Means query to query as the volume increasing, speed decreasing, right? Yes. If volume increases, speed decreases. And if complexity increases also, speed decreases in that. See this queries, right? Select a total amount from sales 1, sum of amount from sales 1. Same table, sales 1, and sales 1. I want to average amount, aggregations. In databases, aggregations, right? Average aggregation, some aggregation from sales. But standard deviation, select standard deviation of amount from sales 1. Which query executes faster among these three? First query, right? Obviously, the first query, right? Because second query average amount is a two-step process. First sum to be calculated, next average to be calculated as compared to the first query. Second query taking more time. And see the third query, standard deviation of amount, lot of internal processing required as compared to the first two queries, right? Yes. Databases, the major drawbacks with the database is databases can handle only structured data. They cannot handle unstructured or semi-structured data. For example, For example, if you want to take reviews for a particular movie, you want to take reviews for a particular movie, right? Yes. User and review. User 1, user 2, user 3. 100 users giving the feedback. 100 users are giving the feedback. First user saying that if the movie is good, they are saying 1. If the movie is bad, saying 0. If the movie is good, saying 1. They are saying the feedback in the form of ones and zeros. The movie is good, 1. If the movie is bad, saying 0, right? Yes. Yeah. Can you write an SQL query? Can you write an SQL query to count the number of zeros and ones here? Can you write an SQL query to count the number of zeros and ones? Hmm. So here, what rows and columns here? Rows and columns here. Yes, single grouping and single aggregation. Select, select a review wise count I want. A review wise count I want. From which table? Reviews table. Group by review, right? This is an SQL query. The output for this review 1 or 0 count 90 people saying the movie good, 10 people saying the movie bad. 90 people saying the movie is good and 10 people saying the movie is bad. Okay. So, okay, you can write query for this, but generally the reviews won't be given in the form of ones and zeros. The reviews they'll be giving in their own text format. Movie is good. Second person saying movie is not good. Third person. In this way, they're giving in their own text format. Now, can you write an SQL query to count the number of goods and not goods? Can you write an SQL query to count the number of goods and not goods? Not possible, right? Even if it's right by using the keyword count, by using the keyword good, right? It gives a wrong computation because even not good has got a good in it. So databases can handle only structured data, unstructured or semi-structured data. Yes, can be handled. Okay. Okay, fine. Before I go with the Hadoop advantages, these are the drawbacks with the databases, right? Before I go with the advantages, right? Hadoop advantages. You need to know something about the Hadoop architecture, right? Just I'll give overview of it. Hadoop doesn't follow client server architecture. Hadoop doesn't follow, yes. Hadoop doesn't follow client server architecture. Hadoop is not for request response. Hadoop is not for request response architecture. It doesn't follow client server architecture. It follows master slave architecture. Single master, multiple slaves. Single master, multiple slaves. S1, S2, S3, so on about Sn. Yes. Single master, this is master node. Yes. Within the, we say master node, name node. Within this master node, we have got a name node. So here we call this as slave node. Slave nodes are data nodes. Why the name data nodes? Because data stored within the slaves, data processed by the slaves. You got any file in Hadoop, data is stored in the form of files. Data is stored in the form of files. For example, each system here S1, S2, S3, right? Each system capacity 1 TB, 1 TB storage, 1 TB, 1 TB. Assume it is of 2 TB size. Assume it is of 2 TB. So this 2 TB cannot fit into any of the system, right? This 2 TB cannot fit into any of the system. So it is divided into smaller parts. It's divided into smaller parts. Each part is stored across multiple systems. Each means here distributed storage. Data is distributed across multiple systems. Data is processed by multiple systems parallelly. So parallel processing and distributed storage, two advantages you can see, right? So this is master node. So if data is stored by the slaves and data processed by the slaves, what master node does? If everything done by the slaves, what master node does means assigning task. See, there are two Hadoop cluster means group of nodes, CPUs connected in a network. There are two types of node, master node or name node, slave node or data node. Master node responsibilities. Master node responsibilities. Task assignment, assigning tasks, load balancing, fault tolerance. See, assigning tasks to the slaves, load, assigning the task equally to all the slaves, balancing the load. Fault tolerance means if multiple tasks are executed by multiple systems parallelly, if suddenly if any system goes down, then in the task of it has to be assigned to another slave that is taken care by master. Health monitoring. Before assigning the task to any system, the health status of each and every system, master node maintains it. Slave node responsibilities, storing the data and processing the data. Slave node responsibilities, storing data and processing the data. Yes. Now, later I discuss in brief in the Hadoop architecture, but now advantages of Hadoop. Unlimited data storage. Unlimited data storage because of a feature horizontally unlimited scalability. Horizontally unlimited scalability. Horizontally unlimited number of slaves. Horizontally unlimited number of slaves, right? Yes. Can be added. This master, these are slaves. S1, S2, S3, so on, Sn. So today, if you are running a business with n number of slaves, assume with 10 slaves, you are running a business. Your business has increased. Your branches have increased. Your customers have increased. It means your data is increased. Means you cannot go with the same number of systems. You need to increase horizontally, right? Horizontally, you can keep on increasing the slaves. If customers increased by 1,000 times, and if data increased by 100 times, you cannot go with the same number of systems. You will keep on increasing the systems horizontally. So horizontally, unlimited number of slaves can be added. Very high speed processing because of parallel processing. Very high speed processing because of parallel processing, right? Yes. So yeah, I said multiple systems are running parallelly, executing a same file. Executing the same file, the file is distributed and stored across multiple systems, and multiple systems executes parallelly, right? Can handle all varieties of data, can handle all varieties of data. All varieties means structured, unstructured, and semi-structured. It can handle all varieties of data, structured, unstructured, and semi-structured. Open source. Hadoop is an open source. No licensing required. Most of the Hadoop products are from Apache, right? Apache. From Apache mirror site, we can download and we can install them. Commodity hardware. Commodity hardware, right? It doesn't mean that you need to have very highly configured systems. Hadoop can run on any systems, right? Yes. So these are the main advantages, right, of Hadoop. Yes. So these are the advantages of Hadoop, right? Unlimited data storage, very high speed processing, can handle all varieties of data, open source, commodity hardware. Yes. The Yahoo, right? Yes. Yahoo has conducted a test. See, Yahoo has conducted a test to check the speed of various databases by taking a table of 100 TB consisting of 1024 columns. Task is sorting based on 16 columns. Time taken by different databases, right? Yes. Oracle has taken nearly 3.5 days. Oracle has taken nearly 3.5 days to process that. MySQL has taken nearly 6 days to process. Teradata has taken 4.5 hours. Netija has taken 3 hours. This Teradata, Netija are specialized databases for data warehouse. Hadoop has just taken 3.4 minutes. Hadoop has taken just 3.4 minutes. Latest version of Hadoop just taken 1.2 minutes. Latest version of Hadoop has taken 1.2 minutes. I said Hadoop and Spark, PySpark. Hadoop has taken this much of time, but Spark, you see, Hadoop, compare Hadoop speed and PySpark. PySpark is 100 times faster than Hadoop. PySpark is 100 times faster than See here, Hadoop has taken very less time, but Spark has got much more high speed, right? I'll be discussing about Spark. But Hadoop and Spark combinedly used today, like Hadoop components, like there are some components of Hadoop and Spark both combinedly used for. So I was saying, right, just previously, Hadoop for storage and processing. Yes, for processing, MapReduce and Spark are used. Yes. And you may ask why databases like Oracle doesn't support unlimited storage? Why databases like Oracle doesn't support unlimited storage? Yeah. There is a limitation for these databases. Databases has got some limitation. Um, Even for databases can go with the number of slaves, multiple number of slaves, but there is a limit on the number of slaves. Databases has got a limit on the number of slaves. Oracle can go maximum with 256 CPUs or nodes, right? Beyond that, it cannot support it. Means even if this 256 slaves gets filled, the performance of the system will degrade, right? Just like a labor example, like your mobile phone has got 64 GB internal storage. If all that 64 GB is filled, it cannot, that means the performance of the phone degrades, right? Sometimes it won't even start. Here also the same. MySQL can support maximum 54, but MySQL Express can go with 256. DB2 with 256, SQL Server. But Teradata, Netezza, and Vertica, they are for specialized databases. For data warehouse purpose, they can go with 512, right? But currently, they are going with 1024 slaves. Teradata and Netezza, they are supporting 1024. But still, we cannot say like unlimited data storage is possible with that. Once the data gets filled, they cannot support data further. But there is no limit on the number of slaves that Hadoop can have. But there is no limit on the number of slaves that Hadoop can have, right? Can go with unlimited number of slaves. Hadoop can go with unlimited number of slaves. There is no limit on the number of slaves, right, for Hadoop. Yahoo, when first time implemented Hadoop, went with 4,000 slaves. Currently, Yahoo going with 12,000 slaves for storing its data. Facebook, when first time implemented Hadoop, went with 8,000 slaves for storing its data. Currently, Facebook going with 42,000 slaves for storing its data. So, yes. So, not like 256 or 512 or 1024, like thousands of slaves Hadoop can have, right? There is no limit on the number of slaves that Hadoop can have. Yes. So Hadoop is proven in the market, storage point of view and processing point of view. Yes. Hadoop ecosystem components, what I'm going to discuss as part of this course, right? Hadoop components for storage and processing, right? We have got HDFS for storage, MapReduce for processing, and Apache Hive. It is a data warehouse kind of an environment in the Hadoop framework. It uses a language like HQL, which is almost similar to SQL, Scoop. SQL plus Hadoop. The first two characters of SQL and last three characters of it forms a scoop for importing and exporting operations from databases to Hadoop and exporting from Hadoop to databases. No SQL like schemaless behavior, right? Schemaless behavior. Schemaless are for random access. NoSQL has got schemaless means, for example, SQL first record to last record, they has to maintain the same number of columns. But in NoSQL, right, record to record, any number of columns can be maintained. First record with 3 columns, second record with 5, Forward record with 7 means record to record, any number of fields or columns can be maintained. So as part of this course, I'll be discussing NoSQL like HBase, Yarn, yet another resource negotiator, Yarn components, Yarn architecture, and I'll be discussing Zookeeper. It controls and coordinates all the Hadoop components, right? Flowmark Kafka, this is for streaming data, for live streaming data, right? For capturing live streaming data. Streaming data means data which keeps on generating, data which keeps on incrementing. Such data we call it as streaming data. So the streaming technologies like Flume Kafka, I'll be discuss, and the major component, right? PySpark, like PySpark core programming, PySpark SQL, like performing some kind of query, and PySpark streaming and PySpark MLlib, right? This is what I'll be discussing as part. These are that. Yes. Yeah. Yes. Before, okay, one thing, just I'll use a small introduction to this PySpark also, right? PySpark. So, a Spark, what is Spark and why PySpark? See, Spark is see, if I talk about this PySpark, right? It is an open source distributed cluster computing framework introduced by Apache Software Foundation, right? This PySpark is a general engine for data analysis, processing, and for computations, right? So PySpark, it is a Python API to use Spark. Spark is an execution model implemented by using Python. We say like PySpark, Python API into user Spark. So PySpark, it is an open source cluster computing, right, for big data solutions. PySpark is the lightning fast technology. PySpark is the lightning fast technology that is designed for fast computation. So it is one of the demanding tool among the data engine is PySpark, right? To work with bigger data sets. So this PySpark is used for creating data pipelines, running distributed SQLs, for ingesting data into databases, running ML algorithms, working with the graphs, working with the DSO streams, and many more, right? Yes. So if you see PySpark, so if you see large amount of data is getting generated through online and as well as through offline, right? So the data consists of hidden patterns, unknown corrections, market trends, customer preferences, all this, and we other useful business information. It is necessary, right? We need to extract some valuable information from that raw data. So we have got many tools available in the market already. Yes, different types of various tools are already available, but they are not that much of appealing, right? So we need a flexible tool to crack this big data and gain benefit from it. So PySpark is a kind of technology. So it's such a kind, right? With very high speed processing, with very high speed processing the huge data at quick time, right? Yes. So Spark, combining Python and Spark is the very efficient way for the world of big data. So that's why Apache Spark community came up with a tool called PySpark, that is Python API for using Apache Spark. Today, if you see, it has got wide usage of PySpark, real life usage of PySpark in the commercial sectors. You can see in for real time processing in banks and financial fields, we use this PySpark to retrieve the customer's social media profile and to analyze useful insights which can help in taking the right decision, right? And also in healthcare, in analyzing the patient's records with the previous medical reports and identifying which patient is likely to face that issue, right? And even in the entertainment industry, like PySpark is used, like the popular OTT platform Netflix using Apache, that is Spark, for real-time processing, for personalized online movies or for web series, is processing nearly 450 billion events per day, right? And even in e-commerce, right? Your e-commerce websites like Flipkart, Amazon, all these, they are using Spark for advertising, for recommendations. Yes, for provides offers enhanced customer experience and optimizes overall performance, right? Yes. So yes, that is, and if you see that what I'm going to discuss as part of this, right? You can see this big data Hadoop introduction to this, right? What is big data? Why Hadoop? Need for Hadoop sources and types, challenges in big. Okay. Advantages of Hadoop, Hadoop ecosystem components, HDFS for storage, Hadoop distributed file system. You need to have the knowledge about it. Means what is HDFS, features of it, name node and data node, HDFS architecture, name node, data node, secondary name node, metadata management, storage and processing, replications, fault tolerance, HDFS commands, map reduce processing, right? Map reduce architecture processing, phases of map reduce, scoop, SQL and Hadoop, scoop import, scoop export, importing data from databases, exporting data from databases, right? Transformations, filtering, merging, grouping, aggregating, so all those we can do during this import operations. Yarn, yet another resource negotiator, speculative execution, speculative job, speculative task. Yes, yarn architecture, yarn processing, NoSQL, types of NoSQL databases, and HBase, NoSQL database like HBase, and Hive. Apache Hive is one of the important component of Hadoop. Yes, Hive metastore, storing data, internal and external tables, working with unstructured data, XML data, JSON data, weblog data, and working with UDF, UDAF, UDTF, right? And with partition table, static partitioning, dynamic partitioning, multi-column partitioning, indexing, bucketing in Hive, and performance tuning mechanism, right? And Hive H-based integrations. And coming to the PySpark, lot of discussion on this PySpark. PySpark introduction, why PySpark, real life usage of PySpark, PySpark sessions, context objects, parallelizing, repartitioning, broadcast variables, accumulators, RTD computations, RTD creations, RTD persistence features, different persistence options, PySpark core computations, groupings and aggregations, single grouping, single aggregation, single grouping, multiple aggregations, multi groupings, multiple aggregations, group by key, reduce by key, various inbuilt interactions and transformations, various inbuilt actions and transformations one by one, and SQL data frame. PySpark SQL concept of data frames, right? Yes. And data frame API, PySpark creating data frames, show struct type, struct field class, row class, column class, select, collect with column renamed, where, filter, drop duplicates, order by, join. Many built-in functions we have got. Platinum and PySpark SQL functions, aggregated functions, window functions, date and timestamp, JSON functions. Many inbuilt functions, no need to write huge codings here. PySpark built-in functions. When EXPR, lit, cat, translate, replace, overlay, yes. Date format, date diff, explode, array underscore contains, list, map keys, map values, struct. Okay, PySpark external sources, right? And working with SQL statements, PySQL and Hive integration, Spark and MySQL integration, Spark and Hive integration, working with CSV files, JSON files, transformations and actions, narrow and wide transformations, adding new columns, dropping columns, renaming, adding of new rows, dropping rows, handling nulls, yes, deployment modes, local mode, cluster mode, stages and tasks, driver and executor, Spark
Excuse me.
pipelines, deploying Spark applications to cluster and tooling.
Excuse
And
me.
yes, yes.
I mean, is it what normally you having demo sessions of explaining the contents, or what exactly is demo all about?
So what I'm going to discuss as part of this course, I'm showing you all that, right?
All
What
right,
is
because
covered in
what?
Hadoop, what is covered in PySpark, everything, the contents, what I'm going to discuss, right, for the next 3 months.
Okay, and normally, I mean, I don't know about others, but I don't know what these components are at all. So there is no point in looking into these components, right?
So I'm just like 2 minutes I'm taking, right? Not taking much time for this.
All right.
So I'm taking the headings only, right? Yes, what I'm going to discuss. Most of the students will ask during the demos what is going to be covered. Based on this content only, right? People will judge whether to join or not.
Okay. Sorry, sir, I don't know that.
Yes. So because what is the course content? How depth? What is the depth of this, right? By seeing the course content only, you can see the depth of that, right? What we are going to discuss about. Okay, deployment modes and PySpark applications and these things. And PySpark streaming concepts, integration with Kafka and PySpark MLlib. So this is as part of PySpark. In depth, in brief, we'll be discussing about this entire PySpark. This is 60% of the time what we spend will be on PySpark only. PySpark has got a great boom in today's market, so I'll be spending more time with PySpark and remaining 40% of the time on this Hadoop and Hadoop components. Okay. There are some other components, right, which got outdated. I'm not discussing about all those outdated components of Hadoop. Yes, which are mostly used. That components I'm discussing in Hadoop and in brief about this PySpark. But the prerequisites for PySpark, right? Python is the prerequisite, right? You need to have total code course in Python. So yes, totally I'll be discussing about this Hadoop plus PySpark, and total everything goes in Linux environment and Python. So yes, this everything is going to be covered. The fee structure is 15,000 for this. And if you already have the knowledge on Python, if it doesn't want Python, right? If you already have got knowledge on Python, the fee structure will be 12K, right? Including Python, it will be like 15K otherwise. So this Python, you people need to attend in the weekday classes, Monday to Friday. Any of my batch, right? Any of my batch can just check with the online team. We have got multiple Python batches going in the weekdays. And for this will be on the weekends, right? The timing will be like somewhere like 2:30 to every week will be like 2:30 to 4:30, somewhere like 2 to 4, 2 hours on Saturday and 2 hours on Sunday every week. And yes, Hadoop first I'll be covering with the Hadoop. By the time I complete Hadoop, right? You people will be done mostly like 50 to 60% of the Python gets completed before I go with PySpark. Yes. Yeah. So that is the course content. Yes. So hope you understood why Hadoop required is for storage and processing services, online applications and batch applications. Hadoop is meant for batch, but not for online applications. Even if you want to perform online applications, Hadoop to perform with online applications, Hadoop integration with NoSQL database performs both batch and online applications. And the drawbacks with the current databases. So why we are going with Hadoop? Why Hadoop is not taking these databases? Why database is not taken for storing its data? Why it is going with a special kind of file system, Hadoop distributed file system, and small Hadoop follows master slave architecture, single master and multiple slaves. And why databases cannot support unlimited storage? They have got some limitation, but there is no limitation in Hadoop. It can go with unlimited slaves. Hadoop ecosystem components. These are the components I'll be discussed as part of this course, right? And yes, yeah. And just 1 second. How exactly the data storage and processing in Hadoop, right? How exactly the data is stored in Hadoop. In Hadoop, in databases, data is stored in the form of tables, right? In databases, data is stored in the form of tables. In Hadoop, data is stored in the form of files. In Hadoop, data is stored in the form of files. Each file is again subdivided into blocks. Each file is again subdivided into blocks. Default block size 64 MB. Yes. Default block size 64 MB. Right. Latest version, right? 128 MB. f1.txt. If you got a file f1.txt, yes, of 200 MB. Right. I got a file with 200 MB. Assume some telecom data is stored. This file in Hadoop, whether it is 200 MB or 200 GB or 200 TB, it's divided. Each file is subdivided into blocks. This file is divided into blocks. Assume 64 MB blocks I'm preferring. So number into how many blocks? This file size by default block size 200 by 64 blocks. Hadoop, a file divided into blocks, fixed size blocks. B1, B2, B3, and B4. B1, B2, B3, and B4. Yes, these 4 blocks stored across 4 systems, S1, S2, S3, and S4. S1, S2, S3, and S4, right? 4 blocks are stored across 4 systems, right? Yes. Yeah. Yes. B1, B2, B3, B4, they are stored across 4 systems. In system 1, B1, B2, B3, B4, 64, 64, 64, and 8 MB. Because 200 MB means 64, 64, 64, 192 plus 8. But 56 MB is free in this. 56 MB is free in this, what? Yes. F2.txt, right? F2.txt has got 192 MB. Number of blocks into how many blocks? File size by default block size. Default block size 192 by 64. 192 by 64 means approximately 3 blocks, B5, B6, and B7. Means this file 2 of consisting of banking data of size 192 MB divided into file size by default block size 192 by 64 MB blocks into 3 blocks, B5, B6, B7 stored across 3 systems. And here B4, there is 56 MB is free. Why B5 data is not stored in B4? Even though here there is some free space available, why B5 data is not stored? Assume if B5 data stored in B4, assume. Why B5 data is not stored in B4 when 56 MB is free? Okay, now check this. I want to retrieve f1.txt. I want to retrieve f1.txt, right? Retrieving f1.txt means b1 plus b2 plus b3 plus b4. I want to retrieve this b1, b2, b3, and b4. If b5 data is stored in b4, assume if b5 data is stored in b4, 64, 64, 64. In b4, 8 MB plus 56 MB of f2.txt data. Total 256 MB you will get. Actual file size is 200 MB, but you are getting 256 MB, which is wrong computation. When you are retrieving telecom data, you are getting a part of banking data. When you are retrieving telecom data, here we are getting a part of banking data, which is wrong computation, right? Design principles with respect to HDFS blocks. Every file should have its own blocks. In a single block, no 2 files data to be stored. All the blocks will have equal volume except the last block. Okay, fine. this default block size, even if you want to configure, if you want to increase or decrease the block size, we can increase it. Go to the Hadoop installed folder. In that conf folder, we see hdfs-site.xml. Within that, yes, open this file, XML file. It will be an empty file. We need to open it and we need to configure. We need to configure that. Yes. What we need to configure, this configuration and slash configuration, property and slash property, name and slash name. What is that? DFS dot block size. What is the value? 50 MB I want, or 100 MB, or 150 MB, or 200 MB. Whatever block size you want, you can configure. So it will be an empty file actually. We need to configure these 4 lines. So we can have our own block size, 50 MB or 100 MB or 200 MB. We can set our own block size. Right? Yes. Okay, fine. So we do one thing, just we'll have the session, right? We'll have some break. Again, we'll continue the session like 1 more hour, right? Yes. At 2:30, right? Again, we'll be back at 2:30. We'll have a small break and we'll continue more on this. Yes. Take a break and we'll be back at. Any queries you got before that, anyone? Yes. Fine. Just I'll keep the meeting in mute.